So here are two more examples where the usual way that memory is allocated isn't good enough. And in these examples, the problem is I'm trying to create variables that are too big. And in general, with the usual method of allocation, there is a limit on how big in memory a variable can be for the compiler to allocate it for you. Now, it's true that you can tweak this limit. It is possible to modify the limit before running your program, and you'd see that in some higher level course. The problem is, no matter what you set the limit to, there is always the chance you might exceed it. And so I want to demonstrate cases where we're creating variables that are so big that the compiler can't seem to work with them. They can't allocate them for you. So the first example is, here is a structure type that I've created that's, contrived. It is customer data, and I want to keep track of the prices of up to 10 million orders. Okay, so this is pretty big. And if we remember from the video about the size of a float is 4 bytes. So this would be 40 million bytes just for this one array stuck inside this structure type. And then I've got this basic program here that inside of main calls a function f. And inside of f, it tries to create one variable of this type, and that's it. That's it. That's all it does. It doesn't even use the variable. And then it prints out this line. And what I want to show is that the compiler can't help with this. So here it's complaining about an unused variable. Fair enough. It turns out we're not going to get much chance to use it. If I try running this program, it crashes. And I really hope that it's simple enough that you can agree the only thing that could be causing that crash is this declaration. Everything else is pretty orthodox. I'm using print statements. That's not a big deal. When I try to create a single variable of this type, the program crashes. And just for clarity, let's see what happens if I comment this out. So we want to be scientific about this. It works. So this seems to be causing the problem. We should know by now a variable declaration is supposed to be innocuous. It shouldn't make the program crash. So what's happening? And it turns out that what's happening is the variable is just too big. The compiler can't allocate that much space using its normal rules. But maybe it's logical. 10 million it really isn't that big a number. I need to be able to store that much data. Okay, there's example 1. What's example 2? Example 2 is something similar. It is a function that attempts to allocate an array of size 10 million. Again, I've chosen 10 million because that's a nice round number that usually breaks the internal limit on automatic allocation. Okay, so just like before, the main function does virtually nothing. It just calls the function f and then has print statements before and after. What does the function f do here? Okay, it creates an array of size 10 million. So there it is there. Then it loops over the array and just sets every value to something sort of irrelevant. I mod 7. Let's actually do I mod 11. I've observed that will have a more pleasing result. But it just sets every element of the array. So all 10 million elements of the array get set to some value. And then afterwards, it computes just by basically taking random elements. It computes the sum of 2 elements of A, just to prove that A got filled with the correct values, and then it prints it out. Okay, let's try running this. Oh, whoops. Here we go. So it's called big array. And same problem. If I try to allocate an array that's that big, the program crashes. And to prove that, let's try allocating an array that isn't that big. So 10,000. We've worked with arrays of length 10,000 by this point in the course. Everything's fine. So if I make an array that's too big, although this isn't that big of a number, the program crashes. So keep in mind, obviously, it doesn't matter what method we use. There are sizes, there are values of n where the computer simply can't accommodate an array that big. The computer only has so much memory. I think this computer that I'm using has 16 gigabytes of memory, which means any individual program, that would be 16 billion bytes or 4 billion ints worth of storage. So maybe I can't make an array of size 5 billion, fair enough, but I should be able to make an array of size 10 million. And it looks as if the normal way of doing things isn't enough for this. I need some way around that. So we've now seen a few reasons why we might need to break the normal allocation policy. Maybe we want to violate the rules of scope. Maybe we just want to allocate something so big that the normal process can't accommodate it. So I think I've proven the point. We need some other option. And the option is something called dynamic allocation. allocation. Or in the context that we're going to use it, manual allocation, where you take over the process of creating the storage for your variables. In exchange, you have more freedom to create variables in different ways, breaking the rules of scope, variables that are very large. But on the other hand, you take on the responsibility of managing that storage across its entire lifespan. You have to create the variable storage when you need it. You have to destroy it when you're done. And we'll see that in the next video.